Hello, everybody, and welcome back to the Rare Network podcast. We are on episode 7 here. I am one of your hosts, Nathan Simone, and I'm joined, as always, by the lovely Rand, Mr. Rand Corp, one of the co-founders of Rare Evo. And we've got a special guest on the show today. We have George Flerovsky. Did I get that correct? From
Excellent.
MLabs. And MLabs describes itself as a Haskell and Rust consultancy specializing in mission-critical software development and cross-team collaboration. It's going to be an episode sort of filled with a lot of technical and educational stuff and then a lot of fun, interesting Cardano stuff. I think we're going to have a lot of fun talking to George. George, how are you? And welcome to the show.
I am great. Happy to be on this show. This is my first sort of podcast in a while. I think I did one like a year and a half ago or something. But, you know, I've been looking forward to joining these things more and more this year. I love talking about Cardano. I love talking about the stuff that I'm doing. I do it a lot in private with clients and colleagues and stuff. But I've unfortunately sort of been neglecting the public at large. And I want to rectify that now.
Well, that's good. We always like having, especially somebody that's technical in blockchain that can explain it to a lay audience. There's definitely not enough of that in the crypto space. There's lots of technical people, and then there's lots of marketing people, and it's hard to sort of find the bridge between. So we're definitely hoping that you can do that for us this show. And I know that your official title is you're the delivery manager at MLabs.
What? I have a funny title. I'm called a delivery manager.
Okay.
And I joke that I'm responsible for ensuring that the pizzas arrive on time for all the developers.
Okay.
But in reality, essentially, MLabs has kind of like a two-tier management structure. So we're a fairly decentralized company, like pretty horizontal. We have clients that come in, we have devs, and client needs something to be done, and we're like, okay, we have these devs available. These are their expertise points or whatever, and it seems to be an alignment there. So we kind of assign some of those devs, expertise, time zone, whatever. And then typically a project will be led by a tech lead / project manager, kind of does the day-to-day, manages the team, manages like the roadmap, looks after the technical spec, and ensures that, that technical excellence is there. And then you have people like me, we call them delivery managers, and we sort of oversee the tech leads. We take a more strategic view and a more horizontal view. So last year, on average, I had about 6 projects, sometimes a bit more, like 8, sometimes a little bit less, like 4, and varying sizes that I was overseeing. I was interacting mostly with the tech leads, but I hopped on dev calls all the time as well, and sometimes hopped on those troubleshooting sessions where, oh my god, this thing's driving me crazy. Plutus is giving me crazy errors. I'm not sure what's going on. And then we find out that it was some pure function because some division is taking forever to evaluate. Not where we expected it anyway. And so I've gotten my hands dirty. I'm good at Haskell. Last time I checked, which unfortunately I haven't done as much coding in the past 6 months. So maybe it's been a little while. But point is, I interact with the day-to-day fairly often, but I'm also like, when needed, and everything's running well, I can just step back a little bit and do a little bit more oversight and just kind of interact more with the leadership of the team.
Well, and so that's a really interesting and unique role. One, I'd never heard of the term delivery manager before. And I wondered if you could sort of talk like a little bit more about what MLabs does, because Haskell being one of the main programming language of Cardano, Rust is used for a lot of other things. And then blockchain and AI consultancy is how you sort of bill yourself. And what you're telling me is you're like, the analogous thing is you're like the head chef in a kitchen, but it's for a technical sense. You're overseeing all sorts of people that do stuff. And then when duty calls, it's like, you got to maybe get in and, like you said, find out that somebody, was using a pure function when they weren't supposed to. I'm not even going to pretend like I know what I'm talking about. I'm not a coder.
No, it's all good. Yeah, so I don't think the term delivery manager, which comes from externally, actually means what I interpreted it to mean. But MLabs we're sort of a very tight-knit, very horizontal organization. We're all on Slack, and anybody can message the CEO just in a DM for anything really. So we're sort of, our roles, we kind of encourage people to take initiative and figure out what the roles mean and what is the best way for them to contribute towards a project. I kind of looked up the definition of delivery manager, which was sort of a flavor almost on project manager. You're supposed to look after kind of the roadmap of the project and the different deliverables and stuff, and make sure that it's aligned to what we're trying to achieve, like the business goals, which probably come from a client, or if it's an internal project, we define them. So you're kind of trying to maximize the success of the project in the business sense, but also in the technical delivery sense. And I took a look at the Cardano ecosystem when I joined back in 2022, January. And I was like, you know what? The biggest blocker I see to delivery, both in the business and the technical sense in Cardano, is the technical complexity and the technical soundness of the protocols of design. Yeah. So why don't I focus fire on that aspect and make sure that I can really get that to be as solid as I can, and then magically the technical roadmaps kind of work themselves out, and the delivery timelines kind of work themselves out if you have something that is just makes sense from a protocol perspective and is built on a strong foundation. And I think actually Cardano's general philosophy is kind of like that too. Let's get the foundation to be technically sound, and then hopefully that allows us to start kind of building stuff up on it in a more rapid pace. Now the rapid pace hasn't quite necessarily happened yet with Cardano, but honestly, it's night and day this year and last year, right? Last year, I had private moments in the spring when I was like, are we ever going to ship anything?
Oh no.
And this was from inside of a consultancy, right? I mean, I had just started, but there was a little bit of pessimism there last year. This year, it's just honestly, developing smart contracts for an application has become fairly straightforward for most app designs out there, where I'm like, I know that we'll get through it. I know what it takes to get the on-chain code to work, the off-chain code to work. Really, the bottlenecks now are just about integration with the rest of the architecture, and that sort of analytics layer that everybody was neglecting last year. Last year, everybody's like, well, we just want to ship V1, and we just want people to be able to click a button and something happens on the blockchain. This year, they're like, okay, we've done that now. We want to understand what's going on in our actual application, what's going on in other applications, and what are some of the ways that we can maybe interact between them, kind of elevating beyond the initial sort of, let's just get V1 to work, right? So.
Yeah, you bring up some interesting technical questions there, and I'll ask you this before I definitely want Rand to jump in with. I know he's always got some questions. Cardano is unique in that it has its own programming language, just like Ethereum previously developed Solidity. But I've heard that over and over again. Once again, it's a non-technical guy. I've heard that Haskell can be a little bit hard to wrangle, to wrap your head around, even for programmers. So I totally understand why MLabs, exists to help out with this. But I'm interested sort of, a little bit in your Cardano backstory and how you've gotten to this point where you're talking to us about what attracted you to Cardano, Haskell, and its unique development environment. And could you maybe speak to, what it is like having to deal with Haskell, which is a completely new and very unique programming language from what I understand?
Yeah, absolutely.
The questions out of my mouth.
Yeah. So my backstory is, well, not rewinding all the way back to birth, but rewinding back to my beginning with Haskell.
Yeah.
Was picture this: I had just dropped out of law school. And I had about, I'm a good storyteller, right? So anyway, I had just dropped out of law school. I realized that the sort of, I'm not meant to be a lawyer. I'm much more kind of analytical from first principles type of thinker, whereas the law tends to be too much bound by historical accident that now just extends as precedent that we must follow, or we must kind of gradually change towards other historical accidents that we managed to accomplish through the court system. And that was not really my thing. I like knowing, kind of being able to derive the whole thing from a small number of kind of initial principles and things like that. So I was like, you know what? I want to move more in the direction of kind of the empirical sciences and the theoretical, economic, whatever sciences. I had an econ background before I went into law, so I was like, well, why don't we just continue that? But anyway, between getting out of law and getting into econ and data science, which was my career pre-blockchain, I had about 6 months where I was just hanging out and exploring things. And I was like, you know what? I've learned two things that I want to figure out. One is I want to learn Linux, and the other one is I want to learn Haskell.
Wow. Ambitious.
Wow. Yeah, that is ambitious.
So I did both. And the reason why I wanted to learn Linux was because it saved my ass with my very last law school exam before I dropped out. I had a 100% exam. My Windows machine crapped out, and I had to figure something out. And then by some stroke of serendipity, someone told me, oh, you should just use a Linux live CD, and you'll be able to read everything off of your Windows hard drive and get back all your notes and everything and be able to continue. Amazing. So he helped me out to get all that set up, and I was able to get back into my study session and was able to go do the exam the next day. So I was like, there's something to this Linux thing, because Windows has always been a pain to install, reinstall, and troubleshoot. And Linux, despite its reputation, seemed to be a lot more approachable in 2015. So that was why Linux. Haskell was because I was already into functional programming. I had used it in school more during my econ degree for various analytics and things like that. I hadn't used Haskell, but I had used the kind of the functional paradigm because I found it to be very clean. Data science and analytics, it's very concerned with reproducibility of the analysis. And so functional programming is kind of very good for that because it allows you to set up a pure functional pipeline from the inputs and the data to the outputs. And you know that there's nothing sort of fishy going on in between.
Okay.
Right. So that's what drew me to the functional paradigm and to the purity of it. And when I dropped out of law school, I was like, what's the purest functional language I can find? And Haskell was it. I was like, all right, I'm learning Haskell. So
wow.
That's how I
so
got into it.
How did you get into blockchain then from there? Was it Haskell led you to Cardano, or did you stumble into blockchain? You went straight in from there. Love it.
Well, so actually, I was aware of blockchain from before. I don't remember how, but I actually ran across the Bitcoin paper back in like 2000 and I want to say 9.
Whoa.
Because I mean, I was in economics. Bitcoin was kind of proposing this weird new currency system, monetary system, and everything. And I was curious about computation and things like that. And Bitcoin was doing some interesting things with like the hashing and the blockchain basically. So I was curious about it. I was like, oh, this is really cool, but it seemed a little bit too fringe. And I had exams coming up, and I was like, okay, well, I'm going to deal with it later. Later never came. So I never became a Bitcoin miner. I never became an early billionaire or millionaire, whatever it is, or bought a pizza with the Bitcoin. That would have worked. One or the other. That never happened. So blockchain was on pause with me for a while, and then after I started learning Haskell, I was on the Haskell subreddit just regularly, and just like reading posts, writing posts, helping people out who were a little bit further behind me in terms of like on their journey. And asking questions of those who were ahead of me. And then I saw there were a few posts kind of mentioning Cardano as a blockchain that's being built using Haskell. I was like, curious. Mm-hmm. And so I just pulled up one of the Ouroboros papers. I started reading it. It was over a weekend. I had some time left over. And I had all the prerequisites for it because with my econ background, I have a good sense for probability theory and like those probabilistic models that they're using to prove blockchain properties. Pretty comfortable with mathematical notation. Very articulate from law school, so able to read these like very kind of fancy language sort of papers. And then the incentives model, right? The various incentives of the players. Due to my economics background, I kind of understood that, in the game theory of it and everything. So I had everything in place, and I was able to just like read through these papers without needing to go out and dig too much into the background stuff. So I got hooked. And then I invested in Cardano.
It was like it was made just for you.
Yeah, honestly, like you couldn't ask for it. The intersection of law, econ, computation, and I guess mathematics or something, and kind of, like you have a unicorn that is born. So I just started reading up more and more on the Cardano, different papers and stuff like that. And then I saw that the incentivized testnet came about for the stake pools. So the Shelley incentivized testnet. That looked pretty cool, but unfortunately I had a day job and I didn't quite have the opportunity to get involved as a stake pool operator, even though I wanted to. So I missed out on that one. I did delegate in the incentivized testnet, but I didn't end up being an operator myself. But my time to actually like get in and be more active in the community came around when the Plutus Pioneers first cohort sign up rolled out. I signed up for the course. I went in and I gave it, I gave it my time. Like I really dove in and tried to learn Plutus and struggled through the initial situation with the tooling and everything. And I got on the short list to participate in the Alonzo blue, white, and purple testnets. Blue in particular was a small one. And I'm proud to say that I think myself and a couple of my other colleagues kind of kicking the tires on the blue testnet, we may have been some of the first non-IOG people to put a smart contract transaction on the testnet at the time. So that was pretty fun.
Wild. That's really wild.
It was. I mean, it sounds cool, but honestly, we were struggling for like 3 days to put the trivial "always succeeds" contract and unlock funds from it. Mainly because there were serialization issues with the testnet and the Cardano CLI, where we weren't able to give the stupid data to the contract in a way that it would understand and will allow us to unlock the funds. And we weren't able to set the fees properly because the fee calculation wasn't there. We had to manually figure it out. It was wild, man.
You were doing some of the foundational work. I'm wondering if you were working with Rob Grigg from Cornucopias back then, because he's a tech OG just like you, and he's been with Cardano since the beginning.
Maybe. Honestly, I know those guys by their Discord handles, I think more. Not many of them I actually got to know by their real world names. Ikigai I met through my days in Plutus Pioneers. Their CTO, Dmitry Safin, we met first day Plutus Pioneers. We started talking and we kind of were talking about our respective ideas for what we wanted to build with Plutus. And then it kind of went from there. He went off to kind of co-found Ikigai Tech, which are focused on their own kind of internal projects that they come up with. I eventually joined MLabs, more of a consultancy side, but I mean, we've been interacting ever since.
Yeah, I'd be surprised. I'd be surprised if you didn't come across Rob. Our podcast with him, Rob Grigg from Cornucopias. He's been in tech forever. He was literally like in tech when like text messaging was like a new thing. So shout out to Rob. I have a lot of love for Rob. I'm just saying that if you were playing around, if you were one of the early Cardano pioneers, especially on the technical side, I'd be super surprised if you just didn't run into him online. You may not have known who he was.
Oh, completely plausible. Yeah. Actually, so UTXO contention is something that came up in Plutus Pioneers first week. Because I was in that discussion with some of the other pioneers because we were sort of playing around with the English auction example that Lars had put up, as like the teaser in the beginning of the course, where like, learn Plutus and you too will be able to write an application like this. Okay. And so we were kind of kicking it around in the Plutus playground, and then myself or someone else, we noticed that if you attempt to place multiple bids at the same time without sort of advancing the time, then the result is sort of seems a little bit arbitrary. It's not the highest bid that wins. It's not the lowest bid. It's just some essentially randomly selected one. Like on the blockchain, in reality, it would be exactly that. It would be a randomly selected one because UTXO contention happens. Whoever manages to grab it first, whoever's transaction reaches the next slot leader first wins, right? So you kind of, Anyway, we can talk about the UTXO contention problem quite a bit later on. But so we kind of ran across that and we're like, oh, wait, So this makes it tricky to manage this sort of shared state for an application like an auction or a DEX or all the other things that we were kind of dreaming up. And we started brainstorming what are some of the ways that we can kind of get around that. And actually, the design for one of the projects that I want to talk about today was inspired, or like the initial idea or early idea of it came from those conversations.
Definitely. Let's definitely do that. Let's get into, so you currently work for MLabs. We've gone over that, on the consultancy side. Obviously a super technical guy from the boot with other multiple disciplines under your belt. Let's talk about that first project. What is it that we're going to be looking at here? Because we do have the video option to look through some of the stuff instead of just chatting technically, and trying to remember that we have a mix of a non-technical and a technical Cardano and other blockchain audience. What's the first one we're looking at here?
So the first one is called Grab It Auction. And so honestly, I haven't been involved in the kind of the front end and the marketing and the release of it and stuff. So probably it would be best for the Ikigai folks at some point to maybe come on your show, or to kind of talk a little bit about more of the user experience of it and like the demo videos and all that. But we can take a look at this. It's on testnet right now as a beta, and they're very rapidly. I think that they're ready to probably go on mainnet today because everything is sort of in place more or less, unless big issues come up during testnet. But they're just allowing everybody to kind of kick the tires a little bit before they do that. So anyway, it's an auction.
Okay.
Fully on chain, right? So entirely on L1, and it resolves the UTXO contention issue. So you can have parallel bids on every auction where the bidders don't interfere with each other, and you can do that without relying on any trusted third parties to actually operate the auction. So anybody out there can actually, like, if they had the option code, I'm not sure if that's been released yet or anything like that. But anyway, you can construct the transactions and interact with the smart contracts directly, right? And there's no special like keys or anything needed that allow you to perform certain actions, is what I'm trying to say. And then everybody gets in, they bid in parallel, and at the end, the auction resolves in a very kind of efficient way, and in a deterministic way that can't be stalled by any participant, not the seller, not any bidders, not anybody. Nobody can prevent an auction from resolving. So, okay. Yeah.
Yeah, no, I see. We've got a whole bunch of stuff here. Everything from the Second Amendment to what looks like. Right?
Yeah.
I want to stop you real quick, George, because you keep mentioning the term UTXO contention, and I'm wondering if you could maybe explain in a minute or less what you're talking about there, especially in a non-technical way. What is this problem?
Absolutely.
Contention that Grab It is fixing.
Yeah. So what's a UTXO? A UTXO is an output from a transaction that hasn't been spent yet, right? So it's literally it's unspent transaction output, right? And typically that UTXO is sent to a particular address. That address means that a certain person or a group of people are allowed to spend that UTXO, or it's sent to a script address, which means that a certain script is responsible for guarding who is allowed to spend that UTXO. And that script is allowed to look at whichever transaction attempts to spend that UTXO. The script will look at the entire transaction, what the inputs of it are, what the outputs of it are, who the signatories are of that transaction, which data was provided by the transaction submitter, and which data is contained in the UTXOs being spent in that transaction, together with which tokens are minted and which tokens are burned. So the script is able to look at all of that and say, all right, I'm happy with what's going on here. There's nothing fishy happening here. You're allowed to spend that UTXO. So that's what's a UTXO. That's what a UTXO is. Now, in the context of like this UTXO contention idea, so first let's talk about where there is no contention. If I send you, Nathan, a UTXO and only your key, only your wallet key is allowed to spend it, there's no UTXO contention because you have exclusive control over that UTXO.
Okay.
Nobody else can interfere with your ability at any time to spend that UTXO, right? The problem comes when if the UTXO is sent to an address that allows, let's say, for example, like it's a native script address that allows either this key or that key to spend this UTXO. Now you have a potential situation where Nathan, you might want to spend it, and Rand, you might want to spend it at the same time. And so on the Cardano network, what happens then is, Nathan, you'll send your transaction to your local Cardano node. Rand, you'll send it to your local Cardano node, either directly a Cardano node that you're running, or one through a light wallet that your light wallet provider is running. And then that node is connected to the rest of the Cardano network. And essentially what happens is every node on the network, including your local node, is going to validate that transaction relative to its current ledger state based on all of the transactions it's aware of so far, including those that are in blocks and those that it is aware of that are queued up, that it has already validated so far. If it passes validation, then it broadcasts the transaction to all of its peer nodes, right? To basically pass on this transaction. And each one of those will do the same thing. So essentially what happens is, imagine, Nathan, let's say you're in Toronto, and Rand, let's say you're in Sydney, Australia, opposite sides of the world. You both simultaneously submit your transactions, and those transactions conflict with each other because they're trying to spend the same UTXO. What's going to happen is your transaction will diffuse through the network, spread out through the different nodes in the network, and eventually meet in the middle. And in the middle, and at that boundary, the nodes that have heard of Rand's transaction first will reject Nathan's transaction because, sorry, UTXO was already spent. Nathan's nodes, the ones that have heard of Nathan's transaction, will say, sorry, Rand, it's already been spent. So now you have the whole world is kind of split in half, so to speak, right? And there's Nathan's side and there's Rand's side. How does this get resolved? Well, Cardano runs a slot lottery among all the block producing nodes, which are distributed among the nodes of the Cardano network. And one of them, so at every second, one of them, or there's a certain chance that each of them has to become the slot leader for that second, right? Sometimes there's no slot leaders. Sometimes there might be two or something. But the point is there's a slot leader. And so whichever side the slot leader happens to emerge, that's the one that will prevail, right? So if the slot leader is on Rand's side, Rand's transaction will make it into the next block. The slot leader is on Nathan's side, Nathan's transaction will make it into the slot. So it's kind of a 50-50 coin flip in a sense, which transaction will win out. And that's the cleanest example of what UTXO contention is.
Gotcha. So definitely we're always wanting to find optimized solutions and solve for UTXO contention, because otherwise we just have like a huge mess with building applications and in general interacting with the network. And so,
where this problem arises when you're trying to develop applications is that typically applications have global state that they want to modify as a result of user interactions. So a DEX, for example, has reserves, let's say ADA and Sunday tokens or something. And if someone is swapping Sunday tokens for ADA or ADA tokens for Sunday, you basically have to go in and put in Sunday tokens and extract out ADA, or put in ADA and extract out Sunday tokens, right? And that interaction there is an interaction with SimUTXO that's holding those reserves. And so if everybody's rushing in to interact with the DEX, and the DEX holds everything in a single UTXO and is designed to just where people are just directly interacting with it, then you're going to run into a situation where multiple transactions are trying to spend the same UTXO at the same time. Only one of them will go through, and all the rest are invalidated because they have to be rewritten to reference to try to spend the UTXO that comes out of that first transaction, right? And so what the industry has come up with is two main approaches to handle this. One approach is called the batching approach, and there what we're saying is everybody that wants to interact with the DEX here in question is going to send in an order which can be picked up and matched with other orders or with the DEX itself. to sort of resolve it, to execute this this order. And that allows you to have people submit these orders all in parallel. And then you have a batcher that comes in, picks up groups of these orders, resolves them all at once, which is more efficient because you can interact with that, with the DEX reserves and process multiple orders at a time. So that's the batcher approach. I think that's the first one that came out, on Cardano, and it's kind of a workhorse. I think Sunday uses it, MinSwap uses it. As far as I'm aware, I may be a little bit out of date in terms of those protocols because it's their in-house teams that are developing those protocols, so I don't work on them as much. The other approach that I've seen some adopt is the TX chaining approach. So there, the idea is that nothing stops you from submitting a chain of transactions, each one of which is consuming the outputs from the previous transaction. You don't have to wait for that first transaction to make it into a block, be confirmed, and then you kind of submit the next one. If you know what the output of the first transaction is, you can send the second transaction right after it, right? Because the way that nodes in the network process their the transactions is on a first come first serve basis. So if I broadcast the first transaction, and my peers receive it, they'll validate it and broadcast it on afterwards. If I then broadcast the second transaction, they'll process it and pass that on as well. And so ideally, if I just do 1, 2, 3, 4, 5, and like in rapid fire, then all my peers are going to be able to process that sequence of transactions, and everything will be fine. Where you might run into some issues is if the transactions in the chain arrive out of order, but that's not necessarily a game breaker. It just means that the nodes that those transactions arrive in, let's say halfway through or a third of the way through the network or something, transaction 4 has arrived, and then transaction 6 got in before transaction 5 got in. Transaction 6 will bounce, right? And then transaction 5 will eventually arrive, right? And then maybe transaction 6 will arrive as well. So the order might work itself out. It just might take a little bit longer to percolate through the network because of that, most of the time. So it's a little bit of a probabilistic thing, but it allows you to just kind of send this sequence of things. So that's great. The problem is, how do you know what the output is of each transaction in the chain if it's multiple independent people trying to construct these transactions? Because if each one is making this independently, it doesn't know who its neighbor is on the left side or the right hand side, and so it's not able to have that information flow. So in the transaction chaining paradigm, you need to have some sort of off-chain coordination to let everyone know what the current tip of the chain is to which you're trying to attach a new transaction. So that's what some protocols out there are doing. I think Optim does it. Maybe some other ones are doing it as well, including some wallets, right? Because honestly, if you have a wallet and you want to send out and you want to just have a whole bunch of activity coming from that wallet, I think Typhon wallet or someone allows you to just have a chain of transactions that you just sign, and then it'll just send them in one by one to its backend node.
Wow.
Very interesting. Yeah, and I can see how that works with like DEXs and having like liquidity pools or like a smart contract holding funds. You have a bunch of people that want to use or withdraw or trade in that smart contract. There has to be like an order to that. Everybody can't just go in at once. Things change. So this kind of puts everybody in an order, basically.
Yeah. So with DEXs, the reason why this comes up, this sort of global state comes up, is because DEXs typically have orders. They have patient people like submitting orders, and they have impatient people. So on a limit order book, for example, the patient people are submitting limit orders where they're saying, I have this order, this is my limit price, right? I will not buy at a higher price than this. I will not sell at a lower price than this, right? And this is how much I'm buying or selling. So they're the patient ones, and they're willing to kind of wait for the price to come down to you if you're the buyer, or the price to come up to you if you're the seller. And then there's the impatient people who are like, I want to buy this much at the best current price, right? And it's the market orders that cause the issue in terms of like the global coordination, because you're essentially saying, find me the best current deal and execute my order against that deal, right? And the best current deal is a local property. Whereas limit orders, if you just come up and you want to match up against it, that's sort of localized to the limit order. Although, on the other hand, the limit order is a deal that is open to anybody, right? Which means that multiple people can come in, and if it's a very lucrative limit order, can attempt to match up against it at the same time. So, limit order based DEXs suffer from this problem as well, and that's why they have batchers coming in and do the matching there as well, similar to how the AMM DEXs do it, right? So yeah, but the trade-off with the batchers is that whoever runs the batchers has discretion to choose which orders they match up against each other, and to split the difference however way they want, right? If I have a buy order, a buy limit order that says I will buy up to $200, and someone else has a sell order, I will sell at no lower than $150. Whoever matches those two orders together theoretically could just take the $50 for himself, right? And there's nothing that you can really do at the on-chain level to prevent that, because when the buyer submits his order or the seller submits his order, they don't know what eventually it will be matched up against, so they can't necessarily specify that restriction, right? And you could say that, okay, in my smart contract, my sell order will look at what order is it's being matched up against, and we'll say, all right, you're only allowed to kind of take this much of the difference, right? But then the batcher still has discretion to match it up with any order they want. So the batcher could actually submit his own sell order, right? That maybe has a higher price. Take that and then quietly, execute the actual sell order that wants to sell it for the lower price, right? So arbitrage is possible for the batchers in the batching system, and it's sort of unavoidable in a sense. And the best you can do really is just monitor the transaction activity there, because it's the blockchain. Everything is there for you to see. And if you don't like what's going on, then you can kind of comment on it, and maybe you can ask the trusted parties of that protocol to follow a particular convention, essentially, of like, okay, we're going to take this percentage as our cut, and we're going to promise to respect the rest. But it's not something that on-chain code could guarantee. Now, I'm going to preempt you here for a second. I don't want to get into the current controversy with some of the protocols that are facing this. And I mean, I don't necessarily know that it is one-sided, because sometimes when things aren't clarified, like, and expectations aren't aligned, people might be expecting two different things, and then they might decide that they're not happy with, one side's or the other side's interpretation of what the deal was, right? So I kind of want to, at least for now, remain neutral in this part, especially because I'm the head of the CDA, and I just want to remain a neutral arbiter there a little bit. So if you'll allow me.
Yeah, completely. It just sounded very similar to what I was hearing, so I wanted to see if that was kind of along that vein. But yeah, completely understand. And we were getting far off from Grabbit here. So back to Grabbit.
Yeah, back to Grabbit. So Grabbit, coming back to the UTXO contention problem, it came up with the auction, very first day of Plutus Pioneers, as I said. The auction design there basically had, for a given auction, a single UTXO that contained the current highest bid for that auction. And then anybody who wants to bid would come in, spend that UTXO and replace it with one that had a higher bid and a higher deposit backing that bid. And then once the auction timer runs out, which also was encoded in that UTXO, then essentially the seller comes in and picks up that bid in exchange for the, and just sends the NFT that's contained inside of that UTXO to the winning buyer, right? Because he had to deposit it in. So with Grabbit, we essentially tweaked that design, quite radically, actually. So what we do is the workflow is this. If you're a seller and you want to sell a token, you deposit it into a UTXO that contains an announcement of the auction terms, right? What's the starting price? What's the bid increment in terms of absolute or percentage? What's the kind of ending time? And so on, right? Who the beneficiaries of the auction are, not necessarily the seller, right? Sometimes it might be for a charity or something, or the proceeds will go to this person, whatever. There's a lot of flexibility there. And in fact, I'm not sure if they're rolling it out in testnet, but it doesn't just have to be one NFT. It could just be a lot of just an auction lot. That's the technical term. But anyway, just a group of different NFTs, like a little bundle. And so then you have two paths that you can proceed along, or two styles of auction. One is called like the private or invitational auction, where potential bidders kind of register their interest to participate, and then the seller lets them in to participate in the auction. And this is great for if you need to do some sort of KYC or whitelisting or any sort of thing for like depending on what you're selling, right? Sometimes sellers want to have that control. And then the other style of auction is the public auction, where once the auction announcement is there, bidders can just let themselves into the auction and then start bidding, right? No problem. So both are supported. And the way that bidders get into the auction is we have on-chain a data structure that keeps track of the current list of members in the auction. In technical terms, it's a linked list where each node in the list points to the next one and also mentions which bidder is associated with that node. And that linked list is sorted by the key of the bidder, essentially, right? And so you can insert very easily into a linked list because you grab any node in the linked list, you attach a neighbor right after it, and you just rewire the pointers, right? And the beauty of this is that this data structure allows you to represent a set on chain, which is great because if you want to ensure that no bid is ignored, then you need to be aware of who the bidders are, right? And you essentially need to have some kind of proof that all bids were considered at the end when you're about to declare who the winner is, right? So bidders enter the auction by inserting themselves into this list and setting up a bid escrow, which will contain their own individualized bid, which they will evolve by incrementing the bid and adding maybe a little bit more ADA or something as a deposit, right? And then the auction starts and bidders start to bid. So each bidder has his own parallel exclusive lane with his own bid escrow that they just evolve up and tick it up. And the Gravit platform is simply displaying what the current highest bid is by taking a look at all the bid escrows. It knows who the bidders are because it knows the set of bidders. It looks up all the bid escrows for them, and then just picks out the largest one and displays that for everybody else, right? And all of this is transparently on chain. You don't even need to go on the website. Theoretically, if you wanted to, you could just query the chain from Blockfrost or whatever, and get that information yourself, and if you're capable of parsing it. So it's all there. It's all transparent. The auction proceeds and does that, and then eventually, when the auction ends, then none of the bids can be incremented up. At that point, this is where the really clever part comes in, because now you kind of have to resolve and find out what the highest bid is. Early on, we thought about just folding over it, which means you kind of start off with a cumulative tally. You look at each bid and you compare it to what your current running highest bid is, and then if it's lower, then it's lower. If it's higher, then it's higher. But actually, what we ended up with for Gravit is each bidder goes in, and if he can show, in fact, not even each bidder, anybody can come in and take any of the bid escrows in there, and if he can show proof that there is a higher bid, then he can refund that bid to whoever that bidder was, right? And so it's just a simple operation. It's all parallel. So if you have 100 bidders, you go in, like 50 of them are going to be able to refund their bids and just get back their stuff because they were losing bids. The next round, 25 are able to do it. The next round, 12 are able to do it. Then 6, then 3, and whatever. And this can be done very quickly, right? Because you don't even have to wait for the blocks because these are deterministic operations, more or less, right? You can just do transaction chaining here as well if you wanted to. So anyway, that resolves the auction in a deterministic way. And as I mentioned, anybody can refund any bid towards that bidder, which means that nobody can stall the auction by saying that, oh, I'm not gonna refund my bid. I don't like the outcome of this auction. I'm going to hold you all hostage until you pay me, right? So then at the very end, you end up with one person who can't show proof that there is a higher bid because he has the highest bid, And with our kind of the set of bidders, every time that someone refunds themselves out of the auction, they remove themselves from the set of bidders. So in the end, you just end up with a singleton set, and that's what you can show to the smart contract to say that I am the only remaining bidder, and therefore my bid must be the winning bid, right? And therefore I can buy the action lot. So,
you know what
really
I think
cool.
So fascinating about this, George. I think that if you ask somebody on the street if we could build eBay on the blockchain and decentralize it, they'd be like, yeah, sure. It's like no problem. But just hearing you explain how technically complicated it is to get it right, to get it correct, and to get it working on the layer one, I feel like I've been just drinking knowledge juice from like a fire hose, you know? So it's like me and Rand are just going to keep giving you chalk, but we might run out of chalkboards here in a little bit. So I can see how people, that's why I wanted to bring up the website too. I think that people sort of poo-poo and they like look at these sites and they're like, oh, it's an auction marketplace. How complex can it be? And, you know, one, I'd like to say, well, show me your auction marketplace that you've built. I'd love to use it. And then second, hearing you talk about how if you want to build it decentralized so that it's fair and so that it's not operating with the blockchain version of like eBay sniping and all sorts of other crazy stuff, it's a technically complex feat. And I just want people to sort of understand that, because I know that we're going to have tech people listening and non-tech people listening to just meld both worlds. It's totally fascinating to me, and I'm just trying to sort of absorb it all right now.
Yeah, absolutely. Honestly, this is one of the protocols that I'm maybe most proud of, and it kind of completes that arc from the beginning of my journey with Plutus, which I'm really happy about. And I've been sort of anxious to talk to people about it for the past like year, because we basically, I think we finished the smart contracts like December or something last year, and Ikigai have just been quietly working out the UX flows and the platform integration and like the sort of smooth experience and the robustness stuff since then. And it's been kind of under wraps, and now they're coming out and announcing it and launching this beta testnet. I've been waiting for this for a while. Actually, I think I might have drunkenly slipped parts of it at Rare Bloom last year. Hopefully nothing too sensitive, but anyway.
That's what we want. Give us the alpha and nobody else the
alpha. Yeah. Speaking of which, by the way, I just want to comment on Rare Bloom last year. I'm assuming you guys, well, Rare is in the name, so I'm assuming you guys were involved with the organization of that. Just want to compliment you on a really kick-ass event last year. I think we sent like 5 people or something from MLabs to that event, and it was at the end of a series of events that we were attending in the region. We flew into Las Vegas for CNFT, and that was actually a really cool event. It was like, I think they said like 2,500-3,000 people showed up in this like big Las Vegas like hall with all these like booths and everything. That was really cool. And then there was a second event that I attended in Las Vegas with a fancier venue. I think they were holding it in the Palatial Wynn Hotel, which I don't know if you've ever been, but that one is like just crazy. It's like, I don't know, it's like Versailles, like Las Vegas style or something, right? But it was a smaller crowd, and it seemed kind of empty. That one wasn't a Cardano event. I think that was a general blockchain event. And you could kind of see the difference in temperature, or like the difference in enthusiasm, and just like builders talking about like, we're here, we're building all this cool stuff and all that. And then after that, we took a road trip from Las Vegas to Denver through Utah. We went to Moab, which was an incredible park. I actually have a breathtaking kind of 360 picture where I was sitting under one of the arches in Moab. And so I'm really glad we took that detour through Utah. And we came to Rare Bloom, and that was really great too, because there you guys managed to draw in all the right like builders and everything, and like so many of my colleagues, which I may or may not have even encountered online, but like we're at the same level where we could talk shop, right? Just like on the like outside of some of like the events that were going on and stuff, and I really appreciated that. So thank you for organizing that last year.
Thank you so much, man. We had a lot of fun. We spent a year and a half planning last year's event. It was a lot of hard work coming to fruition, and I think, if you liked all the technical stuff last year, we have grown massively this year on the multi-chain approach. I think even IO, CF, and Emergo, really, first impressions were real last year. They kind of held off a little bit to see how we do, and now that we've proven ourselves, tons and tons of content for the builders this year. So I think It's going to be 10x better. I think you guys are going to have an amazing time, and I'm excited to get there here at the end of the month. We're ticking away, meeting after meeting every day, making sure all the nitty gritty is planned, and we're ready to party this year. The after parties are bumped up a notch, so I think you guys are gonna have a great time. And we thank you guys at MLabs for coming on boards last year, and then being one of the first to come back on board this year. That's what builds this thing, and it's a community event. It takes everybody showing up together to make it the special fun time. We just do all the planning and put it together, but without everybody showing up and partying, it wouldn't be the same. So
yeah, absolutely,
you guys just as much.
And the partying was pretty awesome last year as well. You had Snoop Dogg's son was there, right?
Yeah,
that was pretty cool. I mean, I didn't get to hang out with him, but I hung out with some of the people who may have received certain gifts from him. So that was pretty fun.
So awesome. Fun part about being in Colorado. And George, I just wanted to clarify, all the glory goes to Rand there. I was not part of Rare last year. I was working for an altcoin exchange at the time, and I could not get out. I was just working. I couldn't do it. So this year, especially
this year, you get the glory.
I had to, wanted to help Rand out, met the team, and it's been fun ever since. So we are definitely looking mega forward to it in approximately 2 weeks' time.
Awesome. Yeah, and for me, this is going to be at the start of my trip this time. So I'm going to go to Rare Evo, and then there's a blockchain kind of more academic style conference in Stanford right after. And then I'm going to head out to PAX West in Seattle.
Oh, that's awesome. Yeah.
So you're going to start off
wanted
with
to go to PAX West.
You're going to start off with a party and end with more academic.
More party.
There.
Okay. It's going to be academic in the middle, and then PAX, right? PAX West is gaming.
Okay. So, I didn't know that. Okay.
Yeah.
Bookend those parties. Bookend.
Exactly.
That's really cool. We wanted to go to PAX West as a team after the event. There's so much to do in the next month or two and stuff after Rare Evo, so that was one we weren't able to get to, but it was on the radar. So glad you get to go to that. I'll have to hear about all the fun you have there afterwards as well.
So you're not going to make it out probably, because you'll be too exhausted from Rare Evo, yeah?
We're not going to make it to that one. It didn't make it on the list. I wish we could have gone though. I do wish. That was one I wanted to put on the list to travel.
Yeah,
so.
I'm also going to PAX West because I'm going to hang out with some of the Ikigai folks. They actually have a gaming studio called Genuine Games, GENUN, and they might be demoing something at PAX West there. They have kind of it kind of came up in the Singapore event I was at back in June. It was like the gaming and Web3 sort of event hosted by Google and like a VC or something. And yeah, they showed off sort of a alpha or a demo version of this sort of like rocket chariot kind of game that they have. So if you maybe have seen Star Wars, you can control 2 rocket engines connected to your chariot or whatever via the 2 joysticks on your controller. And then all sorts of shenanigans ensue as you can also like pop out and like shoot someone in the face as you're passing them by. It's great fun. So yeah, I'm just gonna be hanging out at their studio and play testing.
Web3
Love that.
gaming, heating up so much. We are super early to Web3 gaming. If we're just plain early to everything else, we've been talking about Grabbit here a lot, George. And since you're talking about gaming, I'm wondering, unless we have anything else that we need to talk about with Grabbit, I feel like we've done a pretty good case.
We've done a solid, honestly.
Yeah, we've done a pretty good case study on Grabbit. If you just listen to the Grabbit segment, which I'm sure is 35, 40 minutes long, you'll get the technical deep dive to it. and
Well,
you'll want to use it.
We had it up on the screen, but we talked about it for like 5 minutes overall, right?
You'll trust the public, but you'll trust the public test net when you hear George's explanation of it. I want to definitely move on to, since we're speaking of games, this other game that you have helped called Equine, which is an NFT-based horse racing and breeding game. I'm going to let you take it from here, George. What is this about?
Yeah, so Equine is an interesting game. They're trying to create like a digital version of the horse racing, breeding, and like the stuff that goes on in the real world, right? So essentially, players they can own horses, they can breed these horses. Horses have genetics, and their offspring actually. There's like Equine uses like a Mendelian genetics model to figure out what properties the horse will have. And in fact, those genetic properties are hidden. So the fun part is kind of discovering about your horse as it grows up. I think it like ages 1 year, like 1 year in game for every real world month, right? And kind of all of them get incremented. And then you can enter in your horses to participate in races. The website hasn't been updated yet. We're kind of sort of like that's going to be launched. I think they've deactivated the racing component right now as they are kind of gearing up to release what we had for the smart contracts. So you may be just looking at like a page that just displays something like a placeholder.
They're looking at a page that they only give to Rand because they don't want.
You specifically
on the horses. Right?
No, nothing.
I was trying to connect my wallet. To be honest,
this is so interesting, George, because we recently had Michael Guyon from Decentral Games, who has he has one of the first legal casinos in the metaverse, and I know that like gambling and crypto sort of go hand in hand. This is an interesting thing because horses are pretty, they're nice to look at, they're interesting. I can totally see why they become NFTs. Having been to a horse track and a dog track myself, this is not for me because you can tell me the odds and tell me which ones to pick. It just never makes sense to me. But I find this to be a fascinating use of NFTs that like it has like a game aspect and then it has the gambling aspect. But like what maybe like could you talk about the launch on the testnet? Like what are the specifics here that are making this unique rather than any other racing game or horse game?
Yeah. So I was talking a little bit about like the simulation going on behind the scenes, right? So as I mentioned, the horses, they have their own genetics and properties and things like that, and that's managed using like this sophisticated genetics kind of modeling, Mendelian genetics. And then the racing itself is simulated using physics engine. I think that the CTO of Equine comes from a physics background, like PhD and the whole shebang, and so he built up this whole thing with like air resistance on the horse's face and like the horses behind like the whole thing, right? And in fact, they have they're working on 3D simulations or like 3D renderings of the outcome of the race, so you can be able to see like the horses kind of running neck and neck and stuff like that. So I'm not sure if that's going to be released immediately at the same time as all the smart contracts, or you might get like a more limited version of that. But anyway, the smart contracts themselves, the idea is that we want to make sure that people like lock their horses towards a race, so you don't have this impossibility of like, oh, my horse is participating in like a whole bunch of races simultaneously. That kind of seems a little bit unrealistic. And then the other thing is we want to make sure that the entry fees that are collected into like from the participants on the race and the prize pool and stuff are going to be distributed according to what was announced in the race, right? So when a race is announced, you kind of declare what the terms of the race are, and then you show including the entry fee, the scratching fee. Like for example, if once everybody is entered in, you see the matchups and you also see the track conditions and the weather and stuff. You'd be like, oh, you know what? I kind of feel like I should back out. Well, okay. You'll forfeit maybe like 20% of your entry fee or something, but you can back out and the rest of the people will race, right? So you can get cold feet if you want. And that's something that the smart contracts allow you. But what you're guaranteed is that the fees, like the prize pool, will be distributed essentially to all the participants, right, according to what the outcome of the race is. And further to that, even though the horse properties, like the genetic properties and stuff, are hidden, right? And as I say, that's part of the charm of like you don't know exactly the source code for your horse, so to speak, right? But you can kind of discover it through participating in the race and behavior and stuff like that. And you don't know necessarily the physics simulation itself. That's the element of chance in there, right? But the code being used to run the race and the random seed are hashed and provided. They're locked in when the race is announced, right? So essentially, there's no there's that transparency in there, right? Where you commit to what will be the random seed for the race, then people enter in and put in with their entry fees and stuff, and then you kind of use that same random seed to match them up, and then you run them against each other according to that kind of simulated code with the randomness injected in that very kind of principled way. So it allows you to have that reproducibility and auditability essentially for what is a game of chance, which is something that I don't think you get in Las Vegas, for example, right? You have no idea what's behind those machines, right?
That's yes.
And you have no way to check, and you have no way to reproduce the result. Right?
Yes, and the more I learn about slot machines, the more shady they are after my last trip to Vegas,
to
be honest. Yeah. What I love here is I've gotten really deep into the Web3 games. Zedrun, Pegaxi, a bunch of breed rent Ponzi's that are out there. And I really like this one, that you have like a life cycle. None of the other games I've seen where the horse has a life cycle. So in this, it's not just infinite supply coming up. There's a life cycle to the horse. How is that calculated? Is that over time? Is it amount of races?
Oh, yeah. So this is actually an interesting portion, and it has a technical element backing it, sort of separate from the whole smart contracts. Because how do you manage horse properties on chain in a dynamic way, right?
I love that you just said that.
Yeah. And so the way that we've chosen to do it is to use so far the prevailing standard for managing metadata for all NFTs and really all tokens on chain has been SIP25, which means you just put some properties of whatever tokens you're dealing with into transaction metadata, and then the various services out there that are scanning the blockchain to figure out what the current things are. They have a portion of their indexer which keeps track of this SIP25 metadata and is able to answer queries about what's the metadata associated with this NFT, right? And you could kind of see all of that, and that's what's behind the scenes for all your marketplaces and stuff, your JPEG stores, your end makers, and all of those, right? The problem with SIP25 is that to change the metadata, you have to mint or burn the token, or you have to mint, or to be more specific, you have to mint or burn a token under the same minting policy. So it might be a token with a different token name, but it has to be under the same minting policy, which is a little bit iffy, because honestly, as a token owner, while I might be okay with the NFT creator occasionally being able to update certain properties of my NFT, again, though, there is a little bit of trust that they're doing it in a principled way that is not sabotaging my NFT. But I might be okay with that. But what's worse for me is if they start inflating the, just completely inflating the supply of the token, right? So generally, while most, I think, NFT policies remain open, probably still, it's sort of, you really want to be intentional about when new tokens are minted, and you want to be transparent to the community when that's happening. If that's something that has to happen as a daily operational thing just to update metadata, then it just becomes too much of a slippery slope of oh, whoops, we minted a few tokens there in addition to updating some metadata. So SIP25 has always made me a little bit uneasy for that aspect, that it requires you to mint a token. So to improve on it, because we still like the fact that using transaction metadata to publish metadata about a token is very fee efficient, because transaction metadata is cheap. UTXO datum is more expensive, right? Why? Because transaction metadata essentially goes into history and doesn't need to be kept in right now, whereas UTXO datums have to be essentially kept. Well, they used to be all kept in RAM because at any given moment a UTXO might be spent, and to spend that UTXO you need to access its datum, right? Which means you have to keep it close at hand. Right now, though, the blockchain ledger has grown so large that I think it's being held on disk, but still, regardless, it's being held very close at hand, and it must be managed that way. And so necessarily, UTXO datums must charge a higher kind of fee per byte than transaction metadata. And so for a game that relies on metadata evolving, it seems to be kind of just prudent to at least explore transaction metadata as the medium for us to publish our updates. So that's why we went down that route.
I was going to say, yeah, I love that. I'm sorry to cut you off. I really love how this shows, though, like you're using games and kind of art and fun to like solve real problems that need to be solved by the blockchain to move forward into more serious, problem solving for the world. Like this all builds to something,
Yeah, because now, as a result of developing this game, we have SIP86, right, which is an extension of SIP25. We did the write-up. It's a nice document and stuff, and we've implemented. We haven't open sourced it yet, but we've implemented the indexer that is the evolution of the SIP25 indexer that is now capable of picking up on these SIP86 updates, right? And so what does SIP86 do differently? It allows you to declare essentially what your two keys. There's a main key and there's an Oracle update key, with which you will from now on be using to post updates about the metadata of a token or of a minting policy. And so implicitly in the beginning, when you bootstrap this thing, whoever created a token, if it's a native script-based policy, basically you can extract out the key that kind of authorizes that, and that's your main key and also your Oracle update key. So essentially, whoever holds that key is able to post a separate transaction, doesn't have to do any minting at all, that contains a payload within its transaction metadata that will then update metadata for the various tokens under that minting policy, and it doesn't require that person to mint any new tokens. Plus, we allow them to cycle the keys. So if you control those keys, you can set a new set of keys saying, okay, from now on, these will be the authorities essentially on this metadata, right? And the reason why we have two keys is because in regular usage, you'll use the update key to update this stuff, but you always have your main key as backup in a cold wallet to be able to reassign what the update key is in case it gets compromised, right?
Really cool.
So that's kind of, it's like a key-based approach to posting information that comes from a particular source that you care about, right? And this can be extended, right? So right now it's sort of geared towards the creator of the collection is sort of acting as an oracle about what they want to say about that collection. But you could extend the SIP86 to more of a gossip model, where you could say, all right, so and so is now declaring themselves as someone who wants to gossip about a particular collection, right? And just post supplementary information about the tokens. Maybe those tokens are interacting with their application in some way, right? And that person can start saying something about those tokens. And now indexers can maybe pick up on that if they want to listen to that particular gossiper, right? So there's a lot of possibilities that open up within the gaming space and outside of the gaming space, and there's just so much going on right now with this.
It's totally fascinating, George, because it's like this game has been sort of a proxy for a lot of technological achievements. But what I'm thinking of is I'm almost thinking of it from like a cultural perspective, where the people that are into horses, whether you're racing for them, like looking at them, like taking care of them, that's also a sort of unique cultural element that may have not been attracted to Cardano. I'm thinking about like horse girls, or that guys that like investing in alternative forms of capital, like prized horses and stuff like that. And I'm going to make a bold prediction here, is that this game is going to do pretty well, and there's going to be a horse girl and a guy who's a wannabe jockey. They're going to meet during this game. They're going to fall in love, and connections are going to be made. So it's just going to be a win-win all around is what I'm looking at.
You're a
Wait,
romantic at heart, Nathan.
is Horse Girl the video of the girl going around right now, like running on all fours and like jumping over stuff like a
Oh
horse?
no.
There's, hey, shout out to horse girls.
Maybe.
I love my horse girls, but there's just girls that are obsessed with horses and they're probably not into Cardano. But then you bring the horses to Cardano and you bring guys a lot of ADA who want to make some money doing horse racing on Cardano. It's just sparks are gonna fly. That's what I'm seeing. That's just a cultural layer on the foundation of all the technical stuff that you've built, George. So that's what I want to compliment.
Yeah. See, the thing about real world activities and being a huge like complete fanatic of them is that unfortunately you're not able to devote 24/7 towards them.
Yeah.
So sometimes maybe you're not near the horse, but you still want to get some horse racing in. So you hop on your phone and you do some horse racing.
Here you are.
You look at the training regime of your horse, and I don't know, you breed your horse with some other horse or something, and you kind of entertain yourself that way. That's the beauty of the digital world, right?
That's what I'm getting at. Exactly. It's like, hey, I live in the middle of New York City because I don't. But if you live in the middle of New York
I could take a job in New York City, right? Away from the stable.
Exactly.
Yeah.
How do I visit my stable if I live in the middle of an urban metropolis? I got to do it digitally. And what do you know? I just won 15,000 ADA because I have a prized racehorse digitally.
Yeah.
So
Yeah.
it's just this is in the test net, right? This hasn't actually been launched. I know that Rand tried to connect his wallet. And
I think they're gearing up to launch it on testnet soon. Trademark.
I'm going to predict a positive response, and I'll leave it at that. Predicting a positive response.
Excellent.
They need to incorporate a chat feature, a dating feature for that. That's the least that I'll say on that.
Yeah.
So equine, that's a totally fascinating NFT based horse racing and breeding game. I know that there were two other things that you wanted to talk about, George, and they both to deal with Hydra. I'll let you decide whether you want to talk about the Hydra auction first or Hydrosia. And since we may have some people that are not into Cardano here that don't have any idea what Hydra is or why this would be important, maybe
absolutely
some precursor before that.
Yeah. Right. So let's talk about Hydra first, guys. There's no point talking about improvements of it or applications on it without knowing what it is.
Sure.
So what is Hydra? Hydra is basically it's Cardano's version of Bitcoin Lightning, if anybody is aware of Bitcoin Lightning. Wow. It generalizes on it in several important ways, but the initial spark, I think, kind of came from Bitcoin Lightning.
Okay. Okay.
If you'll excuse the pun. Anyway, so, did I get muted or something?
No, you're good.
No, you're good. You're good.
Oh, okay. It was just the background noise from Rand just cut off, and I was like, "Oh my god!"
Yes,
I feel
Rand
close again.
George, we can't mute you. You're the one who's telling us all this stuff. You're the professor here.
Yeah. Okay.
We mute you, and nothing happens.
So I think maybe the easiest way to think about Hydra is maybe to start with Bitcoin Lightning.
Sure.
Because Bitcoin Lightning is a simpler model.
Yes.
It's a two-person model, and essentially the way it works is two people get together and they're like, all right, we want to hash out some quick deals back and forth between each other, but we don't want to do it on the L1 because L1 is slow and we'd have to pay fees.
Yes.
So they each send funds towards a particular script address, and that script address is just there. It's a glorified multi-sign address, essentially, right? Because at the end of the day, if the two people agree on something and they come back with that to that script address, that's essentially what's going to happen, right? But it's like a version controlled agreement. So it's almost like you send some funds towards a multi-sig address, and with the intent to kind of get into a negotiating room, right? And then you kind of go back and forth in terms of like what you want to do. And every time you kind of agree on something, you'll say, all right, this is our tentative agreement number 15, right? And then number 16, number 17, and so on. And with the Bitcoin Lightning, the way it worked was any one of the participants, once you have once you have agreement number 15, which has been signed by both parties, so both of them agreed, any one of them can bring that back to L1, to that kind of special glorified multi-sig smart contract thing, and say, all right, here you go. We both agreed to do this, and this is number 15. And then the smart contract kind of waits for a little while and says, all right, other participant, can you bring back an agreement that has a higher number? If you can, I'm going to penalize the first person because he kind of jumped the gun bringing back number 15, right? He should have brought back number 17 because both of you had agreed to it. And the intent is for the latest agreement to prevail over all the previous ones, essentially. So every time you agree to a new one, you're sort of invalidating all the previous snapshots, essentially, of what you guys agreed to. So broadly speaking, that's how Bitcoin Lightning works. I may have sort of simplified or slightly inaccurately represented like the specifics of what Bitcoin Lightning does, but that's the essence of it, right? So it's kind of like a version-controlled multi-sig thing. And you could kind of see sort of independently of Hydra, some of the marketplace apps out there kind of were using like something that kind of starts to approach towards that. I think there was a thing called, what was it? Trading Tent or something like that last year. I think it still exists. I'm not sure if it still exists. But anyway, the idea there was that rather than having like an offer and acceptance and everything happening on chain, you kind of hook up people via the website to just have like DMs essentially via the website to figure out what the terms are that they want to do a deal, right? And what they're sending back and forth to each other is like a partially signed transaction. So one person will offer something, sign it, and then if the other person signed it, that transaction is good to go. You submit that, and the trade happens atomically, right? And all this happens just like using off-chain communication back and forth, and only the final result that they agree to gets submitted, to the chain. So that's like a version of what I was describing, but it's not version. The way it works there is you just have a transaction that encompasses the full arrangement between these two people, like in this interaction, and whichever one they kind of end up signing both at the same time, that's the one that gets submitted to the blockchain, and they kind of stop talking after that because the deal is done, right? With Hydra, though, it kind of, or with the Bitcoin Lightning or whatever, it kind of allows you to maybe have several of these going on at the same time, and you're kind of talking about what you want to do, and you're kind of merging that back as like more of a state. Hydra does that. Bitcoin Lightning, I'm not quite sure. And then the other thing that Bitcoin Lightning did was it said that we can actually create a network of these. So let's say Alice and Bob are over here, but Bob is also with Charlie in this other kind of thing going on where they're going back and forth to negotiate. Well, if Bob is a common party between both, there's a clever cryptographic trick where he can sort of commit to Alice to sort of say that, all right, Alice is sending indirectly through me funds to Charlie. And there's a clever cryptographic trick which allows me to sort of do this thing where I will announce this transaction to like each of the nodes along the way, like along the chain. And then once it reaches the final node and receives kind of consent there, there's a piece of information that gets revealed that then is filtered all the way back to all the nodes up to the very first one. And then all of them can sort of submit that, and it takes effect on the chain. So it's this like clever thing, and that's what the Bitcoin like Lightning network kind of uses, more or less. So Bitcoin people might come in and say that no, actually that's not quite how it works. You're wrong on this and that. But for all intents and purposes, at least the way that I look at it, that's how it works. So where does Hydra depart from this? First of all, Hydra allows you to have not just two people, but N people as part of that Hydra head. And so there's N people, they all bring their funds into this glorified multi-signature based smart contract, or not based, but I kind of like to think of it as like a version multi-sig address, right? Where you lock it into a multi-sig with the intent to have like a certain sequence of versions of agreements between the both multi-sig participants. And then once you execute those, then the latest version should kind of prevail, right? So you do that. They all bring that stuff in, and then they spin up an actual formal ledger, like a Cardano style ledger, like a copy of it on each of their machines to handle those, like a mirror image of those UTXOs, but on their ledger. And then they start just broadcasting transactions to each other, right? So if anybody wants to send anybody else within that bubble, any funds, they broadcast that transaction to everybody else, and everybody else kind of keeps track of it. And then the next time there's a new snapshot created, that snapshot leader will just include all the transactions that he's been aware of, right, that he's heard of so far, into the next snapshot, and he sends around the snapshot saying, all right, so I've included these transactions in the snapshot. And each person, if they've seen those transactions, then we're like, yep, I've seen them. We agree, right? And that's the new kind of version of events that everybody has agreed to. And what Hydra allows you to do is you take that snapshot, you bring it back to L1, and you can initialize the closing procedure. Closure procedure is just, okay, great. So the person who initiated it came back with snapshot number 9. Does anybody else have a higher snapshot number, right? And people have a chance, like there's a period of time, speak now or forever hold your peace, to kind of show proof that there is a higher snapshot number. And then eventually it closes, and that's your kind of final snapshot, right? The one that everybody sort of agreed, essentially, that is the final snapshot. And that snapshot essentially can be executed as like, okay, we're going to release the funds inside of the Hydra head that were locked under that versioned multi-sig, kind of thing, out to reproduce the state of the L2 ledger on L1. So the same UTXOs under the same addresses of the same people, right? With the same datums and all the stuff. So, yeah.
Okay, that's fascinating, George. I have a clarifying question. I understand why Bitcoin Lightning exists, because the base chain is slow and then the fees are high. And so with the Bitcoin Lightning Network, it essentially becomes like the payment system that a lot of people thought that Satoshi wanted in the first place. But my question about Hydra is, Cardano is already pretty dang fast, in my opinion, for settlement times confirmation. Certainly much faster than Bitcoin or Ethereum. And so I'm sort of wondering, what is the main benefit of Hydra, that it really is just like the Lightning Network, where it's like, hey, Cardano's fast and now it's even faster? Or are there some other sub benefits of the Hydra sort of implementation that I'm missing?
3 benefits. First benefit is a higher throughput, because if you're just communicating with your peers within that bubble, you can just spam each other with transactions back and forth, and the amount of transactions is just as much as your internet connections can handle. And I mean, you and I were having a video conference here, right? Mm-hmm. So just think about text transactions being sent back and forth. So sure. That limit becomes essentially much higher, orders of magnitude, in terms of the interactions between you and the other Hydra participants and stuff. I mean, obviously, as you have more and more participants, because each of them has to establish peer-to-peer connections with every other participant, it can kind of start to, if once you get past a certain amount, it starts to approach essentially the same behavior as Cardano mainnet.
Yeah.
I don't necessarily have specific numbers for you for how many participants in a Hydra head does it take for you to essentially have the same thing as L1 in terms of throughput and latencies. But anyway, as long as your number of participants is not enormous, you should have a benefit there in terms of throughput. The other benefit is immediate finality. So on Cardano, because we run a probabilistic model or consensus algorithm to determine who gets to mint the next block, and also because that person is random, they may not have heard of the longest or densest chain of blocks yet. It might not have made it to them yet. And so they may be attaching their block to a shorter block or something. And various forks happen, and they have to resolve themselves out before you kind of reach that chain of blocks that is not in dispute, in terms of everybody has this exact chain of blocks in this exact sequence, right? So finality on Cardano, worst case, can take I think it was 12 hours or 36 hours. And again, the reason why there's a range is because there's a certain number of blocks beyond which a node will not accept an alternative fork of the blockchain that diverges from the one that is currently dominant on this node by longer than a certain number of blocks. right? And so the 12 hours figure that I'm telling you for finality on Cardano is sort of like the average case. So on average, a block is minted on Cardano every 20 seconds, right? It can be 8 seconds, it can be a minute, it can be a minute and a half, it can be 2 minutes, right? It's probabilistic because there's a lottery happening every second for who gets to be the next block slot leader, right? Who gets the next block. And so that's the like absolute cutoff, right? So once that number of blocks kind of has happened, any blocks that are older than that in the chain, they're immutable. Like they will never be challenged, essentially, under, I guess, normal circumstances. I mean, obviously, world apocalypse happens, everything goes out the window, right? But normal operation and just the way that the software is written, the software will not accept any forks that diverge by more than that. So roughly speaking, let's call it 12 hours, 24 hours, maybe 36 hours or something like that. That's your absolute finality on Cardano. Of course, the probability that a fork will come in that diverges from your fork, and will replace it, kind of decreases exponentially by the length of the divergence. So really, most often, I think we're talking about replace this one block for this other block, or maybe replace these 2 blocks. 3, 4, 5, it just becomes rarer and rarer. So for all practical intents and purposes, I think 8 blocks, I think, is generally accepted as, or I don't know, how many confirmations do typically like different like websites ask for on Cardano? Is it like 10 or something?
I think it
maybe 8, 10.
That is a great question.
I think it's about that. So let's call it 8, right? So if we say like 20 seconds per block, right, times 8 blocks, that's like a minute and a half, just over, for you to kind of receive confirmation of that finality, where you're reasonably confident that your transaction will not be displaced by another fork being accepted. Now, by the way, another fork being accepted doesn't mean that your transaction certainly is no longer in there, because the new fork might include your transaction, right? It's just that there's a chance that your transaction didn't make it in under that new fork, right? So long story short, finality is something that app developers on L1 have to be aware of and have to be able to react to. Think about DEX trades and things like that, and they have to be kind of able to react to those sorts of things. And maybe they tend to be more conservative on their confirmations requirement, right, before they consider that a certain deal has gone through. On Hydra, it's immediate. So on Hydra, as I said, every time there's a new transaction, you broadcast it to all your peers. And as soon as the current snapshot that's collecting all signatures from all peers is done, like all the signatures collected, the very next snapshot leader will create the next snapshot and just include all the transactions that have queued up, right? And just say, all right, this is the new snapshot. It includes all of them, and broadcast that snapshot to get more signatures. And as soon as the signatures are received for that snapshot, that's all you need. There's no way for you to fork on Hydra. Hydra is a strictly kind of sequential consensus algorithm. There's no slot lottery. It's a simplified consensus model. So immediate finality is one of those things that I think most people don't think about too much, like regular people on Cardano. But it has benefits on Hydra because that allows you to say that, okay, transaction was submitted. I saw it appear in the next snapshot. That's it. I can report it as good as commit, like as good as confirmed on the Hydra head. So, and then as long as at the end, when the Hydra head closes, and you have that period of time for everybody to present the latest snapshot, as long as that's done properly. I mean, the only way it doesn't get done properly is if everybody colludes to sort of ignore the very latest snapshot, right? Which, like it shouldn't happen because people probably have skin in the game, like on the Hydra head, and at least one person will be like, "Hey guys, what the hell? I had a transaction in there, right? Where I'm supposed to be receiving something, and it made it into the snapshot that we all signed." Like that person is just going to submit it during the closing process and just say that, no, I actually have proof that this is the latest snapshot. So kind of what should happen during the closing and like contestation period is that the latest snapshot gets resolved, which means that you can sort of, when you get that confirmation of a snapshot originally, like when everybody signs off on it, you can treat it as done, as a done deal. It's a major benefit of Hydra.
Yeah, so it really is a major technological improvement. And here's sort of another follow-up question, which may be a dumb question, but when we're thinking about, once again, comparing it to the Bitcoin Lightning Network, right? You're just sending Satoshis back and forth. Bitcoin doesn't really have a smart contract layer. Technically it does, but not really.
That was the other kind of benefit. You're running a full-fledged L2 ledger using the same ledger rules as on L1.
So that's what I was going to ask is like, so you can be sending people Cardano native assets, including different Cardano tokens, Cardano NFTs, all that stuff on Hydra, correct?
Yeah.
Gotcha.
The only caveat is that you can't mint or burn tokens on L2 and have that be reproduced on L1 because certain minting policies are not under your control. So you can pretend that you're minting those tokens or burning them or something on L2. But on L1, eventually, whatever agreement you reached has to somehow be executed on L1, right? And so if you don't have the capability of doing that in L1, then that's not going to happen. And right now, the way that the smart contracts are written for Hydra on L1, the ability to like mint arbitrary tokens under arbitrary minting policies that are controlled by the Hydra head participants is just not included in there. The smart contracts there are like, and this is more of an implementation thing. So in the future, perhaps they could support that. But right now, the layer 1 smart contracts for Hydra are just capable of redistributing the funds that were locked into the Hydra head according to the wishes of the group, in the latest snapshot, right?
Okay.
So
fascinating. Yeah. And so this proposal, which is obviously your proposal, we can see your name is here on it.
I haven't even got to my proposal. So, all right. So let's talk a little bit about trade-offs and drawbacks.
It's further improving Hydra, which already seems pretty dang cool now, but still could be improved.
Yeah, so let's talk about a few drawbacks of the Hydra protocol itself, and also maybe of where the implementation is currently, right? Sure. Now, I have a lot of love for the Hydra core devs, so I'm not like, here to give them a bad day or anything. No. This is just kind of like objective properties of the protocol, which I think they would agree with. Like they would say, yes, it is capable of this. No, it's not capable of that, and so on. So, as I mentioned, you have immediate finality and you have higher throughput, but that comes at a cost of you need unanimous consent on everything that happens on L2. So any L2 participant can flip the table, right? And as soon as anybody
from happening,
yeah. So you're not able to repudiate anything that has happened that everybody has signed off on, but you can stop. You can just ghost everybody on L2, and then they have no choice but to go back to L1 with whatever the latest thing that you all unanimously agreed on.
So wait, that's an important point, George. Can you repeat that? That's a current big problem on Hydra is that you can just be like, hold up, and just stop and
you can just ghost all your all the other participants on the Hydra head, and then the ledger on Hydra can no longer evolve any further, and all that the other participants can do is just come back to L1 with the latest snapshot that everybody had unanimously consented before you decided to ghost everybody, right?
Gotcha.
So that's a consequence of the simplified consensus model used by Hydra, which allows you to have immediate finality, right? But requires you to have unanimous consent. And so for zero-sum game type applications like auctions or DEXs, where people are competing with each other's interests, that presents a major problem. And that's a problem that we had to surmount when we were working on the Hydra auction project. Because essentially, if you run an auction on a Hydra head in the most kind of naive, most straightforward design, which would be invite the seller and all the bidders to be direct participants in the Hydra head, and then just ask the bidders to submit bids on the Hydra head, that's not going to work unless everybody is very cooperative with each other and very sort of polite and respects the rules of the game, right? Because from a strictly kind of economic actor perspective, or like just cutthroat perspective, why would I ever sign off to witness your bid if your bid is preventing me from placing a similar bid or even a lower bid, right?
Yeah.
If I recognize your bid, I have to bid higher than you to win the auction. So you kind of have this bootstrapping problem of like, nobody's going to sign off on any bid but their own. And if they do, then nobody else, like the person who got his bid recognized, doesn't have to do anything. They won the auction.
It's so fascinating to hear this, because it's like the technical version of like always carrying around a stink bomb. And if you just don't like what's going on, you can just stink bomb the place, but there's no consequences to you like ruining everybody's day, which I find is hilarious.
Yeah.
And from a game theory perspective is bad. Let's just put it that way.
Yeah.
You can just take complete control and be like, nope, I'm out. I'm taking my ball and going home, basically. And you're like, okay, so.
Yeah. So essentially, exactly. So essentially what you have to recognize is within a Hydra head, you don't want people with competing interests there, because every single one of them has the right of veto for anything like that happens in the future, right? And so running an auction with direct bidders and sellers and participants in a single Hydra head is just a no-go. And this kind of limitation, I think, has been part of the reason why app developers last year have been reluctant to start building on Hydra.
Sure.
Because they look at this and they're like, well, we don't know how to move past this, so we're just going to wait and see, right? And this is why IOG wanted to work with us together to figure out, okay, what can we do about this? How can we figure out ways around this limitation, right? There were multiple things that we proposed. There was a paper that we published on IOG's blog. Let me pull it up.
And so just to sort of summarize what we've been talking about here, George, is that Hydra does have that problem of game theory where people essentially don't have to consent. They can ghost. They can opt out sort of in the most primitive way. You're solving that with this Catalyst proposal that we had brought up here. Now we have another one brought up. And that
solving that with the Hydra auction project.
Yes, okay, which we will get to after this, and then
we're taking a non-linear path through my topics here.
We'll end on the Hydra auction because we don't want to compete with the
Hydra's. I mean, are you guys willing to have me on again, and I can just
absolutely
dive deep on Hydra Zoa? Because honestly, for me, I love all these other projects I talked about, but I sort of saved the best for last, at least from my perspective, because that's the project I'm most passionate about, and that's the project that I'm sort of submitting from my name. So I will be like directly accountable to Catalyst, essentially, for the outcome of the project. And so, I mean, MLabs will work on it. I'll be subcontracting to them, but I want to be in there. I want to kind of be in the driver's seat of that project and kind of be the entrepreneur this time, not the consultant.
We could book this live. Nathan was asking who's going to be our podcast guest next week. So if you want to go round two next week, let's do that.
So, George, I was going to say that you're always welcome back on the Rare Network podcast.
Of course.
What we could do right now, in the interest of everybody's time, is you could just give very brief overviews of it, and then if you really want,
let's just wrap up with the Hydra auction. Yeah, so
we can do it next.
Yeah, exactly. All right. So in that IOG paper, we kind of discussed various different solution candidates and approaches to getting around this problem, and the broad themes are like as follows. So one is we still use a single Hydra head, but we get the participants to participate indirectly in it, right? And the other option is we set up a network of Hydra heads, and the participants are going to be you'll have, each bidder is going to be in a separate Hydra head. So we kind of put them at different corners of the room kind of thing. And then you'll have certain neutral parties within each Hydra head witnessing what those bidders are doing and kind of bringing that information together, right? So we ended up going with the first approach. So we call it a delegated voucher auction, which is a bit of a mouthful, but there's two main ideas here. First, we have the bidders are not directly participating in the Hydra head. And that solves two problems for us. First of all, it's the zero-sum problem. And second of all, one thing I didn't mention is that Hydra Head participants have to be online at all times because they have to be ready to sign off on new snapshots. If any one of them is, sorry guys, I'm AFK, well, no transactions will get witnessed in a new snapshot until he comes back and signs off on the currently pending snapshot, right? So that's a bit much to ask for, sort of casual users of an app that just want to come in and make some bids, right? Like they don't want to be running a server there at all times that will participate in this automated protocol just for the ability to submit bids, right? So what we have is the Hydra Head is being run by delegates. Think of it as like a federation of auctioneers who are independent to keep each other honest, right? And then you can sort of ask them for their professional services of running the auction. Now, as a consequence of that, the second idea comes into play, where we don't actually want to send any funds to the Hydra Head now, because now we're not direct participants in the Hydra Head. The participants, the delegates are in control of everything that happens inside of the Hydra Head. If we were to send our bid deposits and the auction lot to them, they can do whatever they want with it, right? They can send it to themselves if they wanted to, right? So they can rug us on that. Which means that under this model, we're using the Hydra Head to manage information, not resources, right? So the way the Hydra auction works, and this is what we've implemented in the smart contracts for the reference implementation that is on GitHub right now. You could spit it up on your local terminal if you're a Plutus developer and you know how to get all the dependencies, all that. But anyway, in principle, you can do it.
You could do it, Rand. He's looking at you. You could do it.
Yeah, I could do it.
And if you want, maybe, maybe we'll try to do it together in the workshop at Rare Evo. Not sure how ambitious we'll be able to be there because time restrictions and all, but we'll try what we can do. So anyway,
I'm currently doubling your time in the room, George, after this podcast.
Oh boy. We've been talking for like 2 hours, haven't we?
Yeah, you're good though. I love it.
No, we're fine. Yeah, we're fine. That's why we know
totally
we have to do a deep dive and we have to do a follow up or something like that. Like,
right.
Please continue with the overview here, and then
we'll do the wrap up.
Yeah, we will wrap it up.
So our smart contracts, the way we do it is we keep the auction lot and all the bidder deposits. Everything stays on L1, right? And we have sort of let me fix my video. That's still blurry. Anyway, we separate out just a portion of the auction state that has to deal with the bidding, right? Or like what the answer to the question, what is the current highest bid? We separate that out from our auction state on L1, and we send that to L2. And then on L2, now the auctioneers are kind of witnessing what happens to that bid, like to the highest bid. In the informational sense, because the auction lot and all the bidder deposits that back the bid, they stay on L1. The auctioneers don't control them in any way. So then what happens is if it's a private style auction, so remember where I said like sometimes you want the seller to be able to let people in, and this is indeed what we implemented for the reference implementation in the Hydra auction so far. Then essentially what the seller does is he asks any prospective bidder that wants to participate. He asks them, "What's your wallet address, or really, what's your verification key that you want to use to sign your bids when you submit it to the auction?" And then the seller just adds a signature that says, "I'm authorizing this bidder to participate." And then when a bidder wants to participate, they send in a bid, which is the auction ID plus the bid amount, along with the seller's signature that allows this bidder to do this, and the seller's signature of the auction ID and the bid amount. Together, that's the submission. And the delegates, they take that little packet, they create a transaction on L2, which updates the datum of the bid to the correct bid amount and attaches those signatures in it. So now you have that as the new prevailing bid. So this means that because the seller's signature is required, no bidder is able to bid without that signature, and that's kind of, we rely on the smart contracts to enforce that. And similarly, you can't falsify, like you can't forge a bidder signature on a ridiculous bid because the bidder has to sign it. And so what we're relying on the auctioneers here for is the proper sort of resolution of the bids that are being submitted. So we're relying on the auctioneers to select out what is the highest bid, but we're not completely at their mercy here, because what we can actually do is we can ask the auctioneers to respond back to us as soon as the next snapshot makes it in. And in that snapshot, we can ask them to confirm that as part of that snapshot, the current highest bid is this. And in fact, that's sufficient information for us to be able to come back and maybe even close the Hydra head ourselves with that snapshot, right? And then the only thing the auctioneers would be able to do is show a later snapshot that has a more evolved bid. And so the beauty there is that even if a later snapshot, for some shenanigan reasons, where all the auctioneers, I have to repeat, all the auctioneers have to collude to unanimously decide to corrupt the bid, right? Even if that happens, we have incontrovertible proof that at one point, a higher bid was the winning bid than the one that we ended up with at the end. So then you can use that proof to sue the auctioneers if you're thinking like in a purely off-chain world stuff, or maybe even include in some sort of a smart contract some capability to slash the auctioneer's deposits or something and compensate the bidders and the seller for the waste of their time with this shenanigans on L2. So point is that we are relying on the auctioneers to kind of witness the bids and pick out the best bid, but we have ways to detect when they're doing something wrong, and we even have ways to sort of mitigate the other problem, which is that the auctioneers can theoretically censor a bidder, right? So they can be like, Nathan, we collectively don't like you, and so if you send your bid to us, then we're just going to ignore it. We're not going to recognize it, and so you'll never get back any sort of confirmation that it made it into any snapshot on L2. So the way we could deal with that, and this is something that we'll maybe explore in a future evolution of this kind of design, is rather than just one bid UTXO that gets sent to one Hydra head, you split it up into multiple bid UTXO that gets sent to multiple Hydra heads. And then if you're being ghosted on one Hydra head, just send your bid to the other Hydra head. And now there's a larger group of people who have to all agree that they all collectively hate Nathan specifically, right? And then that's the only way that Nathan's bid won't make it in.
I feel like it's happened before. I feel like this entire project has been so that I can finally bid on a decentralized system within Cardano.
Yeah.
Is George working for me? Am I bankrolling him? Is this?
Maybe that's why I'm getting such softball questions here.
George, it's completely fascinating because once again, going back to sort of the original when we were talking about Grab It, I think that if you ask most people, like, how difficult is it to build a decentralized auction system on Cardano? They just have no idea the amount of work that has to go into it to replicate in a decentralized way what you have with a centralized system like eBay or that goes through a company or something like that. And then you build it onto a layer 2 and it gets even more complex, but it also gets better. And my mind is just spinning, frankly. I know that I'm going to be re-listening to this podcast just so that I can download your information that you've given us again and parse it, as slowly. My brain is slower than the Bitcoin blockchain.
And I mean, we can revisit the same topics in a new podcast down the line and just be like, hey, so I've thought about what you said back then, and I want to ask you some more questions about it, right? So I'm happy to do that. And honestly, I'm trying to do more of these media tour things because I think there's a lot of tribal knowledge that is enclosed, among the developers, and the Cardano public is sort of hungry for information that comes from the people working with these things, and we have to give the people what they want, right?
Well, I love learning.
George.
I love learning this info, and as a non-technical guy, I'm not going to be a developer anytime soon, to the detriment of my pocketbook. I just like hearing this stuff explained by people that are very clearly in the know, and that, you know, you've even got a catalyst proposal out. Like it's just the amount of knowledge you have is totally fascinating. Before we wrap up here, I wanted to see, Rand, there was a comment from Marketech that said F Nathan. So it does look like there are people that want to
Oh no, have I started a hashtag?
censor me bidding. And I'd also like us to acknowledge here that why is it that the layer 2s of blockchains are always way cooler and they're like Mountain Dew flavors versus the layer 1s? Like you have Bitcoin, it's like, oh, it's Bitcoin, but the layer 2 is like lightning, you know. Cardano.
Oh, you just mean the naming. You just mean the naming.
Yeah, just the naming. It's like you have Cardano, named after an Italian mathematician. You're like, okay, Cardano, and it's like Hydra. Just the layer 2s are always like so intense and so crazy. Yeah. Maybe that's just me.
No, maybe I think they come up later and when marketing becomes more relevant, and so people like, I did a flashy name for L2. Yeah, I think
they are usually a little bit.
And it was like, you know, some guy wrote a paper and just submitted it and was like, hey guys, I have this cool idea. What do you guys want to do with it? Yeah. By the way, so before we close, can I have 1 minute to do my quick teaser of what Hydrozoa is about?
Absolutely, yes.
So let's start with the name. Hydrozoa is a play on Hydra, and it's basically it's like a class or family of like these organisms that are very, very diverse and very small and lightweight, and kind of they have so many different life cycles, and they organize into these colonies, or sometimes they're solitary or whatever. And I just really like that idea for the thesis of what I'm trying to achieve here, which is I want to make Hydra heads more lightweight and to support a broader variety of different things that you can do with them. And at a high level, what I've zoomed in on as the thing I want to improve about Hydra is the way that you open and close a head and the way that you bring funds in and out of a Hydra head. Because right now, opening a Hydra head is a very a lot of stuff has to be done up front, and a lot of stuff gets fixed in place and only changes at the end when you're closing down the Hydra head. So there's this like complex ritual of handshaking and tokens being issued and things being committed and a lot of organizational work just to prepare to open up a Hydra head, right? And then after you've done that, you've sort of fixed in place who are the participants of the Hydra head and all the funds that have been committed to it. Because currently the way that the implementation for Hydra works, when a Hydra head is open, you can't bring anything in and you can't take anything out without closing the Hydra head. Just a limitation, because with the Hydra auction scenario, the model there was you have sort of like a professional service being offered by these, by this federation of auctioneers. What they would like to be able to do is onboard an auction, process the bids, offboard it with the result, but don't take down the entire Hydra head because of it. Onboard the next auction or onboard several auctions. Who cares? Just, you want to have that fluidity in there, right? And so you want to have that kind of, in the Hydra paper, they call it incremental commits, decommits, right? So being able to bring stuff in, bring stuff out without closing down the Hydra head. And then in terms of opening the Hydra head, the way that it works is you initialize a Hydra head, you give each person a token. That person uses that token to bring in one or more UTXOs to bring into the Hydra head, and then you collect them all and you open up the Hydra head. Sounds nice in theory, but the problem is that it introduces a major bottleneck where you have to collect everybody's stuff together and check that all the tokens have been burned and do all this kind of stuff. So in Hydrozoa, I try to essentially simplify the L1 stuff that's going on as much as I can. I don't think it can be simplified any more than that. And so there, to open a Hydra head, just open a Hydra head, single action with an empty ledger. If you want to bring stuff into it, make incremental commits into it. The incremental commits themselves are very simple. You're just sending you're sending stuff to a multi-sig address, and you're attaching a little bit of information about how you want it to be represented on L2. Decommits on L2 are very easy as well, and they can be processed kind of while the Hydra head is still open, releasing some funds from the Hydra head to the people it's supposed to go to. So a lot of these sorts of things I've tweaked, offloading complexity from L1 to L2, where it is cheaper, easier, and faster to deal with, right? and keeping L1 as lean as possible and as flexible as possible as well. So
crazy.
Yeah.
So 2-3 years from now, when Hydra is the standard with Cardano and everybody's working on it, I want people to reference this podcast and just remember that just like those diligent Lightning developers on Bitcoin, George is out here basically fighting for y'all and helping y'all do stuff in the easy way, and he's doing all the work, okay? And this podcast is proof of trying to improve the system along with the diligent Hydra developers. George,
absolutely.
This has been an incredibly technical podcast, but also a really fun one. Is there anything that we've missed? We've talked about Grabbit, the NFT auction / market that you developed that deals with no UTXO contentions, don't even trust third parties batchers. All auctions happening trustlessly. We've talked about Equine, the NFT-based horse racing and breeding game that I think personally there's going to be some marriages and people that fall in love from. We've talked about your proposals with Hydra. We didn't go too crazy into Hydra because that's a whole subject in itself. Is there anything that we've missed that, that you'd like to talk about or enlighten us, especially when it comes to MLabs? If people aren't convinced that they need to work with you at MLabs, this podcast, you can use it on your resume or on your LinkedIn.
Yeah.
And it's clear that you know what you're talking about.
I mean, we haven't even touched on any governance stuff, Oracle stuff, other DeFi stuff besides auctions. Honestly, there's probably a few clients of mine who are maybe not quite pleased with me for the fact that I ignored them on this podcast.
Okay, well then I'll apologize for you and say
there's more coming.
There's only more coming. We can talk about. We'll just have George on as like our technical consultant.
Yeah, honestly,
I like that.
We can talk about my stuff, or you can just bring me on to be like, hey, George, we're really wondering about this, technical question of the day or question of the week that everyone is wondering about. Can you shed some light? And to the best of my ability, I can do that. I mean, I'm curious about also, Mithril and what's going on over there. It's great.
Yeah, there's going to be a lot of people that are going to want to talk to you at Rare Evo.
That happened to me at Cardano Summit. That was the first time that I met anybody in the Cardano community in real life. Actually, I met Ben from MLabs there, and he hired me 2 weeks later. But I showed up, I was thinking, oh, well, I read a few papers here and there. I mean, I'm probably, just average in terms of my knowledge. I show up and it's like, George, what the hell?
That's awesome. I love that. And that's the power of live events right there.
I was going to say, that George, what the hell, is a massive compliment because you combine somebody that has an econ background, a law background, a developer background, who literally, is trying to innovate on the layer 2 of Cardano. And it's, I don't know, the thing that I like most about blockchain in the crypto world is that it is a largely merit-based system where it's like you can either do the work and you know what you're talking about, or you're just saying Bitcoin and Ethereum and Monero and you have no idea what you're talking about. You're just trying to speculate.
Eventually, the merit will shine through. So, yeah.
Exactly. Well, Rand, I think we're going to wrap this one up here. This has been our longest episode. Our guest here has been George Flerovsky of MLabs. He has a lot more that he's doing besides MLabs, but you can find him at MLabs. I think by the time that this comes out, Rand, you're not going to be able to book discounted hotel rooms for Rare Evo, but you probably may still be able to get tickets.
Tickets will still be available.
We'll still be we're about 2 weeks away from the event right now, but I'm just going to say, hey, go buy tickets and go book a hotel room. Rand, is there anything else we need to say before we ask George where people want to find him online?
This has been a great podcast. Probably one of my favorites. I'm excited to kind of dive in deeper in the Catalyst proposals in the next one, and definitely come on at any time, George. I think you hit it all really well, Nathan, and really we'll see everybody at Rare Evo in 2 weeks. I'm sure George is going to have a long line at the MLabs booth of people that want to speak to him. So this has been fun, and I look forward to next week.
Absolutely. Yeah. George, where do you want people to find you online, interact with you if they want to do anything technical or have, work with you at MLabs or something like that?
Yeah. So I'm on Twitter. Swiftly Unmoving is my handle there. And then So that one is for like casual kind of back and forth and stuff like that. I'm on Discord, Iron Fortress. So that's good. And then if you want kind of a more of a formal type of like inquiry type of thing, you can send me an email, george@mlabs.city.
Very cool.
Awesome.
Yeah.
Thanks, gentlemen.
Thank you very much, guys. An absolute pleasure. And you're wonderful host. This felt like just a natural conversation at a living room table. So
I love it.
I couldn't ask for more for an interview. So
that's what we try to do. Thank you, George, for being on the Rare Network podcast, and we will see everybody soon.